limits. This is the first assignment. Okay. Limits, or limit, is a linear operator. Okay, this is something you haven't heard before, but you will hear through here again. What a linear operator means is something like if I have a limit as x goes to some number, of the sum or differences of two different functions. What a linear operator tells me is that instead of having to add these two together first, I can actually take them separately. So I take the limit of the first one and add it to the limit, or subtract it by the second one. Now this also goes back in this direction. So for instance, you may have a function where this one is undefined, all right? But this one is. So what you want to do if you're given a problem like this is to come back here, add these two functions together, and then see if at your point of interest the sum of those two is undefined, in which case it's still undefined. The other thing this also means is the sum is the product or quotient. So in other words, if I'm multiplying times, if I'm interested in that product, it's just the product of the limits of each one. Or if you're dividing, then it would be divided by that, assuming that this is not equal to 0. Again, you could go this way with it also. Okay, so that's what a limit means, is that the limit of a sum or difference. Okay, if it's easier, is just the sum of the limit of each individual part, and same way with product or quotient. We'll be dealing with a lot of linear operators here, where a lot of times instead of dealing with one big thing, it's easier to break it up into small pieces and deal with each individual one. And that's what this does. Okay, let's look at some examples here then. So let's say h of x equals x squared minus 5x, and we want to find the limit as x goes to 5 of h of x. Okay, well you're sitting there saying, well this is not two different functions. Yes it is. There's f, and there is g. Okay, so what we want to do is rewrite this thing in, where I've got the limit as x goes to 5 of x squared minus the limit as x goes to 5 of 5x. All right, this guy is 25 minus 25, which means it is 0. Let's take a look at another example. K of x equals x cosine of x. All right. There's f. There's g. All right. So I've got a product of two different ones. we want to find the limit as x goes to 0 of k of x. So that's going to be the limit as x goes to 0 of x times the limit as x goes to 0 of cosine of x. That's 0, that's 1. So we've got another 0 limit here. You could graph this and prove it to yourself. Also graph each one of these individually and look at what their limits are. Okay. Polynomials. These are a little bit easier actually. So if you have a polynomial without, does not have wholes or asymptotes, the limit as x approaches some value is going to be the same as what the function is at that value. These are the, now remember, these are the same number, but they're not the same idea. Because again, this is just what happens as it approaches it. This is what the function is. A nice easy way to tell this is to deal with a polynomial we're used to dealing with, like a parabola. I want to find the function at this point. All right. This is f of c. So as I take the limit from the negative direction, it approaches that value. If I take the limit from the positive direction, it approaches that value. So the limit of f of x as we approach c is the same as f of c. Now do not get confused that these are the same number. I mean that these are the same thing. They're not. They just happen to be the same number. Okay, for radicals. So if I want to find the limit as x goes to c of some root of x, okay, and if you remember, radicals tend to look like, at least the parent functions, like this. So if this is c, then this will be the nth root of c, which is f of x. And again, you notice here that as it comes this way, as it comes this way, they both approach that value. So that basically becomes the nth root of whatever that number is. Rationals. These are always a little different, and it's no different here. So trick to rationals. If the limit you're taking doesn't make the denominator equal to 0, then you plug in c. You treat it just like a regular polynomial. However, if it does make the denominator 0, then the first way we're going to learn how to handle this, and we'll talk about several more as the semester goes along, this is the first way to handle it, and this should also be the first way you try to handle it. Factor both In other words, numerator and denominator, and try to cancel out that term right there, which is what makes the denominator equal to 0. So you want to try to get this term in the numerator also, so you can factor it out, and then you take your limit as you would with a polynomial.